the introduction, and also a warm welcome from my side. Quite excited to be here on this stage and present this gateway that I originally initiated this project, but we'll see. We have quite a bit of team now behind this project. So we are already quite a bit behind schedule, so I try to keep it short and concise. And yeah, so just let's get started. Before I get into the details what the application gateway project exactly is, I want to quickly highlight what's the reason why we started developing this gateway. So first of all, as a matter of fact, many organizations moved to microservice-based architectures. And this is true from large-scale companies like banks for online banking, and also for more smaller, for example, new innovative project of startups. But when it comes to security, microservices tend to make it harder compared to monolithic systems. Main reason is that we have more services, more interactions between those services, the attack surface is larger, and those are all security considerations that one should do. Compared to a monolithic system where we might only have a much clearly smaller attack surface. However, security is still a bit of afterthought in many organizations. And from my own experience, I can just tell, if you try to patch security at the end onto a architecture, it is so much harder and more costly than when you start with the security mindset from the beginning. But however, there's still not so much talk about security when it comes to microservices. So this is one of the main challenges when it comes to microservices. But there are also some other challenges, especially in larger systems. One is that OpenID Connect, which is today the standard protocol for really for federated authentication, it's still quite complex. It's much easier than, for example, other protocols like SAML, but still there are a lot of different flows and you need to know what you do, and this can get quite tricky, and it's not really something that is really part of your app. You want to focus on your business logic and not really on the authentication part. And then when it comes to large systems, then you often see that those microservice architectures are really closely coupled to the way you authenticate your users. And from an architectural point of view, this is really unfortunate because you have this really tight coupling. And if you want to change something on your authentication system, then you really need to change a lot on your backend. And this makes it hard to keep up with modern authentication. So the OWASP application gateway project was initiated due to those challenges. And yeah, I'll come to in a minute to what it exactly is. But before that, maybe a short view on the team behind it. We have a few open source contributors, and the lead of the project is a co-lead between Patrick Stegel, who is a principal security architect, also at Zülke Engineering, and my humble self, who I am a security engineer and security tester, also at Zülke. And yeah, by the way, we're also hiring. So if this is something that interests you, then yeah, just write me a note. So what are those challenges with those microservices? Here we have a sample microservice architecture. And this is really a typical architecture. As you might see, there are a browser client, the mobile app, then there are some services which are exposed to the internet, and the reporting service who is not really needed to be reachable from the internet. So I just wrote here a lot of different questions that might come up, but they're often quite just simplify to the main questions. How can we integrate authentication in this system? Because we have a lot of different needs. For example, these services are most of the time implemented in a stateless way. So we want to keep that stateless. However, we still might want a server-side logout and other security considerations. And on the left side with the clients, we have the challenges that the browser has way less of possibilities to safely store a credential than, for example, a mobile app where you can store a long-term credentials in, for example, the iOS keychain. And there you want really to have a long-term login and don't want the user to log in every time when he opens the app. So this is about the authentication. And then you so often have an external identity provider. This might be, for example, a social login. This might be your own ERM system. This might be your Azure Active Directory, whatever it is. Main question is always, how can we integrate this identity provider to this architecture? And this is now where the OWASP application gateway comes into place. So what is it? The gateway itself, it's a standalone application, and it's a reverse proxy that sits between your web application or your clients and your backend services. So it's a typical HTTP reverse proxy, but compared to, for example, API gateways, as you might know it, there are a lot of products. It has some kind of special features and is focused on we call it application gateway and not API gateway, because it does quite a lot of things for you. First of all, it does session management and login with a federated authentication provider. So it implements OpenID Connect and takes kind of this responsibility, so you don't need to do that on your own. So the idea is really that it gives you a head start when setting up your security architecture, which leads to a really secure architecture, which is ready from small to large scale systems, like for example online banking systems. Because we believe that every application, also small applications, deserve good security. And from an architectural point of view, the most important feature is that it decouples your backend service from your single sign-on integration. Because this was the point that I mentioned before, that we have this tight coupling often between the backend services and UEM, and Gateway is kind of a thing between and can make that or decouple that. So if you would want to use the Gateway in your architecture, of course, there's some advantages and some disadvantages with every architectural decision. On the advantage side, we have clearly that it comes with a lot of out-of-the-box functionality when it comes to session management and login. So you really need to write almost no code in the backend nor in the front end to do any kind of login-related stuff. So in a large extent, it reduces the complexity in the front end and backend, and you can really focus only on the business logic. From a security perspective, it's also a single point of entry, which means that you have a clearly defined attack surface, and it also makes it much easier to, for example, implement trust zones with network policies, because you only need to expose your instance of the gateway. Then also from a developer perspective, or from an architectural perspective again, the API is the contract, so it allows you to make changes in the backend without changing anything in the front end. This is a clear advantage. This pattern is also called backend for frontend, if you wanted. And of course, it comes with a lot of best practices when it comes to security. So for example, it implements request tracing according to W3C standards. It logs all requests that it forwards. It comes with CSRF protection. You can modify headers and so on and so forth. But also, of course, there's some slight disadvantages. First of all, that's the most important one. It's obviously a bit more complex architecture. But on the other hand, you have a bit less complexity in the front end and back end. So this is kind of a trade-off you need to do. And then also, because it's a single point of entry, it's also a single point of failure. We will cover later how we address this problem with horizontal scalability. And then, of course, while the OHE is really configurable, it's still opinionated in some areas. So we have a kind of idea how an architectural vision with the zero trust approach. But if your vision doesn't match that at all, then the OHE might be not a good fit for you. So this is now really theoretical. I'll do now a short demo of an application that is implemented with the gateway. You see here the architecture. So this is all deployed on Azure, but this doesn't really matter for the demo. The only thing the client talks to is the gateway itself. And then we have 3 backend systems. First is a host for the front end. This is a simple Azure Blob Storage. And then we have 2 Azure App Services, one for the backend API, and one is a special Echo service that is just here for debugging and demonstration purposes. But before I show you that, I want to quickly show you how this is now configured, because this gives a very good impression how OHE works. So let me quickly change the window. Then I need to stop the share and do it again. So what you see now is the configuration file of this OHE instance. And you can see it's a YAML file, so it's easily human readable. And this is also the idea that you can read this file and you directly get an impression of what is going on. There are 2 main parts. There are routes definitions. So here you add different backend routes, and you can have a pattern that matches the request, and then it gets forwarded to this request. And you can have, for example, additional settings, like if this route can be accessed in an anonymous way. So this is the first important part. Second important part is here the login providers. Here you tell the gateway how exactly users can log in. And we have also 3 methods here. So the first one is a login with Google. This is a simple OpenID Connect login, and those here are the values that I got from Google when registering this login with Google. And then we also have a login with GitHub. GitHub doesn't implement OpenID Connect. This is kind of unfortunate. They have their own protocol, so we also built that directly natively into the application gateway. And just for demo purposes, we also have a third with a private ERM. There are a lot of additional things you can configure. For example, how this jot token looks like that is sent to the backend. But this is optional, so you don't really need to configure that if you just want to take the out-of-the-box version. So now let's go to my browser window, and then I can show you how this looks like. So this is the URL of the demo, ohe.azurewebsites.net. Feel free to also go here. It's a simple blogging application. Currently, we don't have any articles here. If we want to create one, let's sign up for that. And here you see now these 3 login links. This now needs to be, of course, implemented by a front-end developer, because we don't really know how you want your login page to look like. But when I click here on the button, this is a simple redirect to a special URL. And this is called auth Google login, for example. And if you redirect the user to that URL, OHE knows that you want to log, or that the user wants to log in with Google. So let's do that. And then we start the OpenID Connect flow. I'm already logged in at Google, so there's no password prompt, but I can now select my account. Let's take my OWASP account. I get redirected back to my OHE instance, and then you can see I'm logged in. Also, I have my nice little profile picture. If you want to know what's going on the backend, you can now use this special echo route. What this service does, it just reflects the HTTP request as it gets it. Then you can see what the gateway does. What's interesting is, most of all, this authorization bearer header. This is now added by the gateway. And here we have a JOT token that can be validated by the backend in a stateless way. And if we take a closer look, we see here now that we have the information, for example, which provider did the user use, and also, for example, here the subject claim, which tells the backend unique ID of the user. There are a lot more things that you can configure. Also, for example, we have a session ID directly in this JOT token. This is the session ID we have here with our cookie-based authentication. If we take a closer look at that, we can see here that we have a few cookies set. Most important here, the session cookie. This is a encrypted cookie. So, but this is kind of not your business. This is OAG internally. So there are also a few other things. For example, here the traceparent header. This is an ID which is generated by OAG itself, and is used with every log statement about this request, and then forwarded to the backend. So if you also log this ID, then you can really achieve a nice cross-service log correlation, and especially for larger systems or in larger systems, this gets really important if you run into issues and need to debug something. So that was it for the demo. Feel free to check it out by yourself. I'll go back to the presentations, and I think because we started a bit late, I'll need to jump over a few slides. But what I wanted to show you is here this this overview over the design principles behind the OWASP application gateway. This is kind of from a user perspective, what's important for them. So the first, and in my opinion, most important one, is that it's secure by default. This means the default settings, default functionalities, and so on are built in a way that they are kind of follow current best practices and lead you as a user to a kind of zero trust architecture, which we think will be a good fit for the future. It also means that if we add a new feature, we try to design the feature in a way that is hard to misuse. But this sounds really easy, but it's actually quite complicated. It also means that the gateway itself is kind of opinionated in some areas. But we know, of course, that there are always special considerations, especially when it comes to larger systems. Then it's really important for you that it's built to be extended. The gateway itself is based on a Java Spring Stack. So you can add your own beans if you want, and add your own functionality and whatever you want. For example, if you want to change the logging system, you can do that. If you want to add support for new authentication methods, something else than OpenID Connect or GitHub, you can do that. That's very simple. I think really important for larger systems. And the last design principles behind the gateway is that it's really configuration based, or that the whole configuration is based in this one file I showed you. This is important because it allows you to just take a look at this configuration file and you know what's going on. So there's no login where you can log yourself in and, for example, add routes in a graphical way. We believe that this file-based configuration is much better for transparency. And also allows you, for example, to add this file to a Git repo, and then, for example, automatically deploy it via CI/CD. And I think this is a really good way to avoid misconfiguration vulnerabilities because the changes are really transparent. So we have 5 more minutes. So just very briefly to mention, internally, we have a non-blocking network stack. This is important for when you have a lot of concurrent requests. We didn't implement it by ourselves. This is based on Spring Cloud Gateway, which is really a mature gateway product that provides this HTTP forwarding functionality. And we have a stateless architecture. Wherever it works, there are a few areas like server-side logouts. There, for that, we still need a little bit of state between different nodes, but we keep that. We try to keep that minimal. But that's one topic we really are working on right now. If you would want to use it, there are two usage models. The first is that you run it out of the box, and I think for small to medium-sized project, this is totally fine. Then you just can run the Docker image, or there's also a Java jar release if you want to use that. Then you just need to tell the gateway where to find the configuration file, and it will start up. If you want to extend, you need to use Java and Spring Boot. Then you can create your own project and use this annotation, enable OWASP application gateway, and then directly add your own functionality, add your own Spring filters, can add your own Spring beans and whatever you want. About the current state, it's still work in progress, need to say that, but we expect to deliver a first a productive usable version as soon as we have built this clustering mechanism. The latest version, it contains all the features that I presented right now in this abstract, except of this cluster support I mentioned. So if you want to try it out, feel free, pull it from Docker Hub or check out the GitHub page. Also, if you want to find out more, check out our GitHub page. There we have a lot of code samples, documentation, even documentation how to extend it and so on, and how to integrate it. Please also store it on GitHub. That's something which really helps us to get some more visibility. And also can check out the OWASP website. There's also some additional information about the project. At that point, I also want to mention, we're always looking for contributors. That doesn't only need to be coding. You can also just write us a note, what you like, maybe feedback, maybe ideas, what feature you would expect from such a gateway. And if you want to code, feel free. We are always happy if we have new open source contributors. Sometimes we also have, even if it's just a little thing, but that's really exciting if someone develops something that's a feature. So please, if you have questions about the development, please don't hesitate to contact one of the project leaders, so either me or Paddy. Yeah, that's it. I'll hang around in the Slack for questions. Feel free to join, and yeah, we'll be happy to answer some questions.